So this is an example of AI, but using PHP instead of Python. As you can see, I'm drawing a character on this canvas, and then we're turning that character into an image. Then we're posting that image to a PHP backend, and then we're getting a prediction as a JSON response. So I've just drawn a 8, and I've got a number 8 back there. So the reason I even embarked on this project was because I saw a video from a guy called Kiraa.ai, and he basically said,
And that's because the entire data science ecosystem runs on Python. Python has become the lingua franca of the AI world.
and this is obviously true. If you search like learn data science on YouTube, you're going to see a ton of videos which like explicitly have Python in the title. But my favorite language has always been PHP, and this kind of got me thinking: is it possible to build AI with PHP? So there's a library called the Fast Artificial Neural Network, or FAN for short, and it was written by a guy called Stefan Nissin in 2003 for his PhD computer science project. As you can see, there hasn't been a stable release in nearly a decade and a half, but there are PHP bindings for this, and the documentation for this is actually on the official PHP documentation website. So this is not like some kind of strange, like esoteric project. It's actually endorsed by the PHP like maintainers. So this is the project we're going to use to actually build our neural network for this AI project. So today's video is sponsored by me. I'm a PHP and TypeScript expert with over 15 years of experience building production APIs and SaaS solutions. I'm available to hire on Upwork, where I have over 100% job success. If you go to my website, which is anthonybud.io, that will take you to my GitHub page, where you'll be able to find links to my Upwork and my Calendly. So to get started with this project, I cloned the official PHP fan wrapper from GitHub, and I looked in the examples directory, and there is actually an OCR example. So if we open up train OCR, you'll see that it's actually quite a small script. Actually, it's actually not that complicated. But the problem is if you notice, it says it loads this OCR.data file and then trains using that file. So the problem is that it loads all the training data into memory, and it also kind of locks up the terminal. So you'll see it says, echo training OCR. Then it will basically do nothing for like hours at a time, depending on the settings you've set up for the network. And then it will finally, at maybe 4 hours later, say done. Okay, we've trained, and it'll output that network to a file called ocrfloat.net. So this is a good starting point, but we're going to have to improve this a little bit to make it a bit more usable. So before we get to any development, we're going to need a data set to actually train this neural network on. So I recommend going to the NIST website, and they actually have a database of over 800,000 handwritten characters. If you download this byclass.zip file, it's about a gigabyte, but that contains a ton of images that we can then train our neural network with. So once you download and unzip that directory, you'll see inside there's 62 subfolders, and they all have like a number and a letter next to them. These are hexadecimal encoded ASCII characters. So if you type in 6e in this hex to ASCII converter, we see it's lowercase n. So if we open up 6e, train 6e, you can see there's thousands of images inside this directory. These should all be a lowercase n, and that's exactly what these characters are. So this is what we're going to use as our training data for this neural network. So first we're going to require this helpers.php file. Then we're going to create a couple of variables. And this is just going to be for configuration of the training and the network. This is going to make it a lot easier to do some experiments later. So instead of defining the network as individual variables, we can define them as an array. And this is going to make configuration much easier in the future. As you can see, the input layer is a 64 by 64, which I'll explain in a moment, and the output is 62. This is all the individual characters that we have in the training data. I'm going to define some computed variables. This is just going to make like the coding easier when we get kind of more into the weeds. Now we're actually just going to create our neural network. There's actually only a few lines we actually need to do this. We're going to use the splat operator to turn the network array into the arguments for the fan create standard function. Then we're going to define our activation functions and our activation functions for output, the training algorithm, and also the learning rate. So now we're going to create a function called generate training sample. This is where we can generate a single training sample. Instead of loading all of our training data into memory at once, we can just create some training data from the NIST data set and then pass that to the function, to the training function, as and when we need it. So first we're just going to load a random directory from that training data. We're going to then convert based on the path, we can figure out what the character we're trying to actually guess is. Then we can convert the hexadecimal into ASCII readable character. For the sake of like user experience, we're going to echo the character out onto the front end or onto the terminal, so we can actually see what characters we're training on. It just makes it lets you see that it's actually training rather than it's just kind of stopped doing something. Character position is where we get the character position in the string of chars. This lets us figure out the output activation node that we want to turn on when we activate or when we do the training. Then we load any random training image. So as you saw, there was thousands of images in each directory. We're just going to pull a random image, and then we're going to do this function here called image2array. And I'll explain what that does in a moment. What this function does is this will load a load random image, and it will convert that into a flattened 64 by 64 image. And that's what we'll use as our input for the activation function. So now we can get into like the meat and the potatoes of the actual training here. So we're going to create a couple of variables to track which epoch we're in and the current error rate. Then we're going to put all the training actual code inside this while loop. This way we can exit the training when we reach the desired error rate or when we exceed the max epochs. Now, the beauty of doing it, of like kind of training using the training function here, is we specify the training data variable, which obviously by default will be false. And then what we do is we use this function called fan create train from callback. What this will do is this will create training data using this callback function. Right now we're passing it an anonymous function, but that function is getting the training sample data and returning an array with the input and output variables. This is how we're going to train the actual neural network. Again, we're using the fan train epoch. Instead of training on all the data at once, which won't give us any output in the terminal, we're training using individual epochs, so we can actually see the training as it's happening. Every nth epoch, we're actually going to save the training data. That way, even if this is running for hours on end, we can always test the current network in its current state. This is going to make kind of like development much easier. Then finally, if the while loop actually clears and you go through it, we're just going to save the output network to the output network file name, and then we're going to use the fan destroy to destroy the actual network, and then just echo out some training information just to help us kind of understand what we've just done. So now let's go back and have a look at this generate training sample function. This function returns a tuple basically with an input and an output array. And this is what we want the network to train. So for this given input, we want this output. What we can do is we can go to the, here we can just go echo JSON encode. Now, if we run that script, you'll see we've got an array of just tons of ones and zeros here. So if we first highlight all of that output, and we see we've got two arrays there. If we go new file, v alt z So now we're highlighting all the zeros and ignoring all the ones. And as we adjust the wrapping on this single one-dimensional array, you can see that there is clearly an E symbol. This will help you understand the input that we're giving to the network. Although it's a one-dimensional array, it wraps round. So as you can see in this example, this is exactly what we're doing with the image. We're going from pixel to pixel and converting each pixel into a 1 or a 0 based on if it's been filled in with the pen or not. And then we're converting that two-dimensional 64 by 64 image into a one-dimensional array of just ones and zeros. Then if we go to the output, we can actually see that it's all zeros, but there's a one here, and the rest of the array, the output array, is zeros. If we go to helpers, we have this variable here called chars, which shows all of the characters that we can output to. If we remove the commas from that string, you can see that the 1 aligns perfectly with the 1 for E. So the input and output function is working as expected. So you can remove that, and now we can actually start doing some proper training. So you can start the training with Docker run, and you can use the command php train.php, and that will start the training script. Once you've started the script, it will output all the configuration information that we're actually training on, and then it will start generating training data. So as you can see, it's echoing out each character as it's loading them from the training data array. And so it's getting capital G, it's converting that image into that one-dimensional array, and then it's adding that to the training data, and then it's going to character T. And it will keep doing that, and every kind of 100 epochs, it will then generate a fresh batch of training data, and then it will do it again, another 100 of training data, until it's done all 10,000 epochs of training. So once the training is finished, you'll be able to open up http.php, and you'll see there's a variable called network file. If you update this variable to the file name of the network that you just trained, you'll then be able to go to Docker and then run docker run and just start the PHP fan container. That will start Apache, and you'll be able to go to localhost 80, which will load this very simple web interface, which has a JavaScript canvas where you can draw any character. When you hit the check button, it will send this PNG image back to http.php. It will convert it to a one-dimensional array and input it into that neural network. And then it will guess what the character is based on the training data. So that's basically all for this project. All of the code that you would have seen in this video is available on GitHub at github.com/AnthonyBudd/AI with PHP. And again, you can find all of my other projects at github.com/AnthonyBudd.